Everyone, welcome to the study of complex number. Today we are considering what is referred to as Cauchy integral formula for one factor, and we are considering a function f of z, which is a complex function, and it is an analytic. Analytic means it is continuous and it is differentiable. So an analytic function is a function which is continuous and it is differentiable. So this complex number or this complex function f of z, it is analytic on and inside a contour C. A contour C, and at a point z is equal to a. The point we are considering is this: z is equal to a in C. Then I repeat, f of z is analytic on and inside the contour C, and z is equal to a at a point in C. Then integral of f of z divided by z minus a around this contour, it will be given by 2 pi I multiplied by f of a. Now, in the case a is outside the contour C, then the integral will reduce to 0. Will reduce to 0 because the sum of the residues outside the given circle is equal to 0. Now, in general, if f of z is analytic on and inside a contour C, and the z is equal to a point A inside, then integral of f of z over z minus a everything power n is equal to 2 pi I multiplied by f of a power n minus 1 divided by n minus 1 factorial, whereby f of a power n minus 1 is the n minus 1 nth derivative of f of z, the given function at z is equal to a. At z is equal to a. So, for example, you are told to evaluate this function. Evaluate exponential 4z divided by z minus 1 power 4. So, by Cauchy integral theorem, this will be equal to 2 pi I f of a n minus 1 divided by n minus 1 everything factorial. Now, in our case, first of all, we identify the pole. The pole is at z is equal to 1. Z is equal to 1, and it is of under 4, and it is inside. It is inside. Now, in this case, you are given that C is the circle and the Z is equal to exponential. So, what we are going to do now, by applying this theorem, we are going to substitute here. So we shall have integral of exponential 4 power z divided by z minus 1 power 4 is equal to 2 pi f of 1 power 3 divided by 4 minus 1, which is equal to 2 pi. There is I here. This is factorial. F of 1 by 3 power 3 over 3 factorial. Then we want to find, we shall find f of, note that f of z is equal to exponential power z. So we are going to differentiate this function f of z. We shall differentiate it the first derivative, which will give us 4. It is going to give us 4 exponential 4z. Second derivative, it will give us 16 exponential 4. Then we differentiate it the third time, f of z. The third derivative will give us 64 exponential 4 power z. Then from there, we obtain that derivative of this function at 1. Where you have z, you substitute it with 1, which will give us 64 exponential 4 1, which is equal to 64 exponential power exponential 4. Exponential 4. Once you obtain that now, we come back to our formula, which was integral of exponential 4z divided by z minus 1 power 4 d of z, which is equal to 2 pi r f of a power n minus 1 divided by n minus 1 factorial, which is equal to 2 pi I divided by 3 factorial. Then we multiply by this part here, which we have obtained as 64 exponential power 4. Now, 3 factorial will give you 6. So this is equal to 2 pi I divided by 6 multiplied by 64 exponential 4. So finally, our result, that is C there, integral around the contour C of exponential 4z of z minus 1 power 4 is equal to pi I over pi I divided by 3 multiplied by 64 exponential 4, which of course we can write as I 64 over 3 pi exponential 4. That is our result by use of what is referred to as Cauchy, by use of Cauchy integral, by use of Cauchy integral formula. Thanks so much for taking your time to study with me. For more such learning on complex numbers and on how to get integral of complex functions at a given contour, kindly tune on to my YouTube channel so that we may keep on learning together. Remember to give me a thumb up. Remember also to subscribe to this channel so that you not miss a single video which I upload for us every day as we keep on learning. Also, you can share with other mathematicians. Also, may you give me a comment so that I may know what other approaches do you think we can use to simplify this working. Bye bye. See you in the next study as we continue learning complex mathematics.